Hello my dear students, welcome back to NEET World. So today we will be discussing the mole concept that we have started yesterday. So mole concept is one of the most important topic of complete chemistry. I can say for complete science subjects itself it will be useful. Even in the physics also you will be using this mole concept when you are discussing about a little bit about atoms there. Okay, so let us discuss about this mole concept very clearly once again from the last class itself. Okay, so whatever I have given the introduction part of mole concept, here I will be explaining you once again in a quick manner so that you will get complete clarity on this mole concept. Okay, so once look at this, in the last class we have discussed about atomic weights and molecular weights, if you remember. So what do we mean by atomic weight? It is a weight of one atom considered as atomic weight. Okay, whereas if I take a molecule, how a molecule will form? By combination of same atoms of an element or different atoms of elements combined to get a molecule. Okay, so now every molecule has some weight, that is what molecular weight we will be saying. So here I have mentioned ethyl alcohol. So in the last class I told you how to calculate this molecular weights and all, and also I given I think so 5 questions as a homework. Okay, and I asked you to mention the answers in the comment box also, right? So from that I will be giving you few examples here. So sulfuric acid is one example I have mentioned in the last class. So before this let us take one smaller one and we will conclude here. Okay, so here we will be taking something like C6H6 I am writing. So what do we mean by C6H6? It's a chemical formula of benzene. What is that? Benzene. It's an organic compound. Okay, so no worries, you just follow me here what I am explaining. So how many carbons are there in the given compound? 6 carbons are there. C6 means. Okay, now each carbon has its own atomic weight of 12. How many units? 12 units. So 6 into 12. Okay, atomic mass unit you can say, or simply unified mass units U you can say. Plus how many hydrogens are there here? 6. So 6 into each hydrogen atomic weight is 1. So 6 into 1. So totally it will be how much? 72 plus 6. So 78 will be the atomic mass units or unified mass units of benzene. So what is atomic molecular weight? Sorry, molecular weight of benzene if they ask, you should say it as 78 units. Okay, hope it is clear. Right. So can we do that same thing for the sulfuric acid also? How many hydrogens are there here? 2. Okay, 2 into each hydrogen atomic weight is 1. Why we are saying atomic weight of hydrogen as 1? So whenever we are calculating atomic weights, we need to take number of protons plus number of neutrons. So in hydrogen atom, number of protons are 1 and number of neutrons are 0. Then overall sum, number of protons plus neutron, total sum is how much? So 0 plus 1, that is 1. So that's why atomic weight of hydrogen is taken as 1. And we have 2 hydrogen atoms now. So 2 into 1 plus. Okay, how many sulfur atoms are there? 1 sulfur atom. So 1 into, okay, sulfur atomic number is how much? Sulfur atomic number is 16. So what is this 16 indicates? Yes, sulfur has 16 protons and 16 electrons, as well as in the nucleus along with the protons there will be 16 neutrons also. So how many protons it has? 16 protons, and neutrons are also 16. Okay, don't worry about electron. Electron mass is almost negligible compared with the proton and neutron masses. Okay, so that's why you add proton, number of protons plus neutrons, how many you will get? 32. So it means sulfur atom is 1 into 32 you take. Plus how many oxygens are there here? 4 oxygens are there. 4 into, and oxygen atomic weight is how much? Atomic number is 8. So atomic weight will be double of it. So that will be 16. Okay, so upon simplifying this, you just try this. So 16 4s are 64 plus 32 plus 2. Okay, how much it is? 8, 98 units. How many? 98 units. Like this, we need to calculate the molecular weights of the given compound. Okay, like that, how many examples are given? 6 examples mentioned in the last class. If you haven't seen that video, please watch it. Try those questions and let me know your answers in the comment box. Even if you are doing any mistakes also, not at all a problem. You mention your answer. If there is any mistake, I will correct in the comment box itself. Okay, right. Let's move forward. Okay, so these are the few more questions I am giving you. Just you calculate them and mention your answer in the comment box. Okay, right. Next question. Here, the next we have started discussing about mole concept. So what do we mean by mole? I told you. So whenever you go to a market, you are going to buy something like apples, eggs, bananas, something like that. So what you will ask generally to the shopkeeper, you will ask, give me some half dozen apples or half dozen bananas, something like that, or dozen bananas, dozen eggs. So this dozen is a number, like dozen is a unit that is used to express 12 units. So if I say dozen units, it is nothing but 12 units. Okay, so similar to this, in chemistry we will be using a term mole. So what is this? Mole. So mole is a term we will be using to indicate this many number of particles, 6.022 into 10 power 23 particle. Sir, why do we use this mole as a concept here, mole as a term here? Because even if you take small quantity, of any chemical substance, for example here in this cup there is salt here I am taking. See, even if I consider this small amount of salt also, it contains many particles, many sodium atoms and many chloride atoms will be there, ions will be there. So now if someone asks you to count how many sodium atoms are there or chloride atoms are there in the given salt, it is highly difficult because atom cannot be seen with our eyes only. So it is difficult to do count manually like this. So that's why there is a term we are using here, mole. So this 1 mole indicates this many number of particles. So when you take 6.022 into 10 power 23 sodium particles or any particle you take, that indicates 1 mole of that units. If I say this many units, so 1 mole of that units. So if you go to market and say, I want 1 mole of bananas, so they should give this many number of bananas. See how huge number it is, 6.022 into 10 power 23. So that's why this number is used in the chemistry point of view to discuss with the very micro level particles like atoms, electrons, protons, like that. Okay, right. Next one, here if I say half dozen, what do you mean by half dozen? Half dozen means, like dozen means 12 we are saying, and you are going to market and saying half dozen. So half dozen means half of the 12. So they will give you 6 bananas, 6 apples, half dozen means, right now. So similarly if I say half mole, so what do we mean by half mole? Half of this number. So half of this number is how much? Divide that number by 2. So half of that number is 6.022 by 10 power 23 means you can write it as 3.011 into 10 power 23. Why? What I did here? So 1 mole means this many particles. Half mole means half of that. That's it. Like this, you need to understand this mole concept topic. Okay, so do not worry or do not get confused what mole means. I hope it is clear from this discussion. ఓకే, అర్థమైంది అనుకుంటున్నా. డజన్ అనే పదంని మనం ఎలానైతే వాడతామో మోల్ అనే పదం కూడా అలానే. ఓకే, జస్ట్ అలా అర్థం చేసుకోండి. ఓకే, నెక్స్ట్ this whatever the number we have taken here now, so this number is called Avogadro number. What is that number called? Avogadro number, indicated with symbol Na, Avogadro number. Na represents what? Avogadro number. So any substance, if you are taking 1 mole of any substance you take, it contains how many that particles, or that how many particles and molecules you will be seeing. Avogadro number of particles you are going to see there. Okay, I hope this is clear. Right now for example, someone comes to you and they will ask you something like this. I am giving you 6 grams of carbon. How many grams of carbon? They will give you 6 grams of carbon atoms they will give you. Okay, so 6 grams of carbon is nothing but, you know, now coal, like coal, coke we will be using. Okay, so that coal they will give you some 6 grams and they will ask you, hey, just count this, how many carbon atoms are there in the given 6 grams. They will ask you like this in a funny way. So you are going to calculate like this? No, that is not required. So just use mole concept here. So what to take? So number of moles you calculate, number of moles you need to calculate. So number of moles, how you are going to get these? Very simple. How many grams of carbon atoms they have given? 6 grams, no? So take here 6 grams. Okay, now divide that 6 grams of carbon with its molar mass. What I am saying? molar mass. So every substance has something called molecular weight or molar masses. Okay, so we discussed about molecular weight, atomic weight now. So what is that molecular weight, atomic weight? So weight of one atom is called atomic weight. Similarly, weight of 1 mole of atoms is called molecular weight, molar mass. So what do we mean by molar mass? It is the mass of 1 mole of particles, 1 mole of carbon. Here it is saying the carbon, like this, 1 mole of substance. Okay, so now what is the weight of 1 mole of carbon atoms? Means it is 12 grams. How many grams? 12 gram per mole. Okay, so here 6 grams is the given weight, and what is its molar mass? For every substance there is a particular number. Okay, that number you take here as a molar mass, 12 gram per mole. Okay, it's easy, no worries to take here. So this is how many moles? Now 1 by 2 mole. So you got half mole we got. How many moles we got? Half mole. So the given substance 6 grams of carbon is nothing but half mole. So half mole means what you can take? Half into Avogadro number, 6.022 into 10 power 23. So how many times it will be? So this is 3.011. So how much it is? 3.011 into 10 power 23 carbon atoms are there in the 6 grams of carbon atoms. Okay, I hope it is clear how we are calculating. So in the same way, can you do one question I will give you? Can you do one question I just wanted to mention here for you? Yeah, so can you do one question for you? I will be providing here. So what I'm mentioning here is 12 grams of carbon. So in 12 grams of carbon, tell me how many carbon atoms are present? Carbon atoms are present. So how can you do this question? Tell me. I just mentioned here 6 grams of carbon and I am asking you how many carbon atoms are present. Same way, given 12 grams and how many carbon atoms are present. What to check? First find number of moles in the given substance. Take given weight of that carbon by its molar mass. What is the molar mass of carbon? I told you 12 grams right now. So 12 gram per mole, that's it. So divide that 6 by 12, here also 12 by 12. So 1 mole. 1 mole means Avogadro number. So how many particles are there? 6.022 into 10 power 23 particles are there. Like this, you can approach a very basic questions first. Okay. Now let me give you a few more examples here. Before that, just read this definition once again. Okay, so now look at this. The mass of 1 mole of entities is expressed in grams is called molar mass. So what do we mean by molar mass? Mass of 1 mole of entities is called its molar mass. So you take any substance of 1 mole, if you weigh them on a weighing bar, you are going to get some weight right now. So that is its molar mass. Okay, so what are the units for molar mass? Gram per mole. So it is also called as gram atomic mass or gram molecular mass. So sir, how can we remember this? Just simple. See, when I told you carbon atomic weight, what you did? Carbon atomic weight you have expressed as 12 units. How you expressed as 12 units? Because you told that there are 6 protons and 6 neutrons. So total sum is 12. So it is atomic weight. Whereas its molar mass also same. Its molar mass or molar weight also same. But you express this in grams, like 12 grams per mole. Okay, if you take 1 mole of this carbon substance, you are going to get it as 12 grams. Similar to this, anything you take. So sulfuric acid we have calculated previously in just 10 minutes back. So how much you got? 98 units AMUs as its atomic weight we got now. So its molar mass also same number, 98 gram per mole is called its molar mass. So if you take 1 mole of sulfuric acid, how much weight it can be now? 98 grams. 1 mole of sulfuric acid if you take, what is its weight? 98 grams. Like that you need to understand. Okay, so even if you take anything like glucose C6H12O6 we have considered. So what is its molar mass? If they ask, first you calculate molecular weight 180 AMUs or 180 you got. So take the same value as molar mass but in terms of units like this, gram per mole. So it means 1 mole of glucose if you consider. So how much weight it can be? It will be like 180 grams. Okay, 180 grams of glucose is nothing but 1 mole of glucose. Okay, ante for example ఇది ఎలా అర్థం చేసుకుంటారంటే ఫర్ ఎగ్జాంపుల్ ఒక యాపిల్స్ 12 యాపిల్స్ నేను వెయింగ్ మిషన్లో మెజర్ చేస్తున్నప్పుడు లెట్ us say అదొక 1 kg ఒక 2 kg ఉందనుకోండి. 12 యాపిల్స్ని మెజర్ చేస్తున్నప్పుడు ఎంత ఉంది? 12 యాపిల్స్ని అంటే డజన్ యాపిల్స్ని మెజర్ చేస్తున్నప్పుడు ఎంత ఉంది దాని వెయిట్? 2 kgs ఉందనుకోండి. అంటే సో 2 kgs రిప్రజెంట్స్ 1 mole of 1 dozen of apples అని అర్థం. 2 kg apples represents 1 dozen of apples అని అర్థం అక్కడ. సపోజ్ ఐఎమ్ సేయింగ్ లైక్ దట్. అలానే 180 grams గ్లూకోజ్ తీసుకున్నారు అనుకోండి, అది ఎన్ని మోల్స్ని రిప్రజెంట్ చేస్తుంది అన్నట్టు? 1 mole. అంటే 1 mole ఆఫ్ గ్లూకోజ్ అంటే హౌ మెనీ పార్టికల్స్ ఇట్ హ్యాస్? 6.022 into 10 power 23 గ్లూకోజ్ పార్టికల్స్ ఆర్ దేర్ ఇన్ దట్ 180 grams of glucose. అలా అర్థం చేసుకోవాలి. Okay, right. I hope this basic understanding is clear. Guys, if there is any confusion, please let me know. If no confusion, click on the like button. Yeah. So now I will be giving you few questions here. See, the number of moles in 28 grams of nitrogen atom is. See, they have mentioned it as nitrogen atom now. So nitrogen, what is the atomic number of nitrogen? We know 7. And what is its mass number? We know it is 14. Okay. So what is the molar mass of nitrogen now? 14 gram per mole. This is the molar mass of nitrogen atom, not molecule. Atom. Okay, so now what they are asking, number of moles in 28 grams of nitrogen atom. So number of moles, N I am indicating. So what is the given weight? Given weight is 28 grams, right now? So 28 grams. And what is its molar mass? We got 14 grams. So take here 14 gram per mole. Okay, so gram cancelled. So 14 2s are 28. So what is the answer we got? 2 moles of nitrogens we got, nitrogen atoms. How many moles? 2 moles we got. So what is your answer? It is second option. And one more thing here I just wanted to ask you. So how many nitrogen atoms if they ask? Number of moles is 2 now. So 2 into, we know 1 mole contains Avogadro number of particles, right now? Ne Avogadro number of particles. So multiply with that Ne. So 2 into Avogadro number means how much? 6.022 into 10 power 23. Okay, so 6 2s are 12. So 12.044 into 10 power 23 nitrogen atoms are there in these 28 grams. Like this, by knowing number of moles, we can easily calculate how many particles are there, how many nitrogen atoms are there in that quantity of substance. Okay, right. Next one here, mass of 2 moles of nitrogen atom is. So they given it as 2 moles of nitrogen atoms. So how can you say? So number of moles means we have calculated this like in here what I taken, number of moles means the weight of the substance given in grams by its molar mass I have taken. Molar mass I have taken here, which is having units as gram per mole, right now. So now what they are asking in this question, mass of 2 mole of nitrogen. See, when it comes to chemistry, sometimes we use word mass, weight, no worries, consider both of them as same unit here. Okay, so now what we required here, weight of that nitrogen atom we required. So what I can do, I can send this molar mass towards this side. So N into number of moles into its molar mass. How many moles they have mentioned? How many moles of nitrogen atoms they have mentioned? 2 moles. So 2 into what is the molar mass of nitrogen atom? So nitrogen atom molar mass is 14 gram per mole, right now? So take here that 14. So it will be 28 grams. Okay. So now what you understand from this? Sometimes they give you the weight and they will ask you number of moles. Sometimes they will give you number of moles and ask you to calculate moles. Okay. So this interconversion is very, very important. Okay. What is important here? Interconversion of one unit to another unit. So now let me conclude that here in this small table you can write these formulas. So what is the first formula I wanted to give you? Number of moles. Number of moles indicated with the symbol N, which is equals to given weight, which is equals to given mass of the substance by molar mass of the substance. For example, I am giving you 8 grams of methane. What I am giving you? 8 grams of methane. Calculate number of moles I am asking. How many moles it will be? If I ask like this, so what you need to do? Number of moles of methane is equals to given weight of methane by its molar mass of methane. Okay. So how many grams it is given? 8 grams of methane is given. You take it here. Okay. And what is the molar mass of methane? We know. So molar mass of methane means carbon is 12, hydrogens 4 are there into 1. So it will be 16. So 16 gram per mole. Okay, you can consider it like this. So 16, 8 2s are. So half mole of methane is provided. Like this, if they give to convert given mass, if they give the quantity in mass, then you can easily convert into number of moles by dividing it with molar mass. Okay, once again, number of moles equals to given weight by its molar mass. What is that? Given weight by its molar mass. So now what is the units for mole? Mole itself is a unit here. No, nothing to worry. So for given mass means for mass, weight, we have grams as units now. For molar mass, what is the unit? Gram per mole. Okay, always whenever you are dividing mass with molar mass, gram get cancelled, so your answer will be in terms of moles. Okay, like that. Okay, sometimes we have one more relation now, using that also we can get. So 1 mole of any substance you take, how many particles it is going to have? Avogadro number of particles you are going to have. How many particles we are going to have? Avogadro number of particles. Avogadro number means 6.022 into 10 power 23. Don't forget this number. So this number from now onwards it will be there throughout your life. Whenever there is a chemistry, this number will be there. Okay, try to remember that. Okay, so now 1 mole of any substance means Avogadro number of particles are there. Now what I am saying is, I have only few x number of particles. Okay, sometimes they will give you x number of particles, like instead of saying Avogadro number of particles, they will give you some 10 lakh particles are there. Then how many moles it will be? How many moles it will be? How many number of moles it will be? How many moles it will be? So what to use here is unitary method, something called unitary method. So here they will ask like this. Okay, so simply you need to calculate number of moles. I will give you one question so you will feel more clear. Just listen to this. Number of moles is equals to okay, you are multiplying this number with this and this number with this. Given number of particles, given number of entities or particles by Avogadro number. So what do we mean by Avogadro number here? So it is 6.022 10 power 23. Okay, that's it. Okay, let me give you one example. Given 3.011 into 10 power 23 methane molecules. Then calculate, they will ask you like this, then calculate number of moles of methane, and second question they will also ask you what is the weight of this methane? Weight of methane in grams. So like this they will make you two questions by giving some data. So what you are going to do, first you calculate moles from the given data. So what to do now? See how much quantity they given, 3.011 into 10 power 23 now. So when they give particle numbers, divide that particle number with Avogadro number. So it means methane molecules, the number of moles of methane will be taken as how many methane molecules provided? Provided is 3.011 into 10 power 23. Okay. Now what they are asking, number of moles. So divide these with Avogadro number. Avogadro number means 6.022 into 10 power 23. So these numbers are almost 2 times. So 1 by 2 mole. So half mole we got. How many moles of methane we got? Half mole of methane we got. So first question is done. Number of moles of methane is half mole. This is done. Then the second question, if you observe this B, what is the weight of methane they are asking? How can you solve this? See, once after knowing number of moles, we can do it. Number of moles is equals to given weight of that substance by its molar mass. We have a formula. So now I want weight only, this numerator I want. So I can say N into molar mass of the substance. How many moles we got? Half mole of methane. What is the molar mass of methane we know? So molar mass of methane, like this you can write. So for carbon it is 12, hydrogens are 4 into 1. So this is 16. So half into 16. So it is 8. So what is the weight of methane we have here? 8 grams. How many grams? 8 grams. It means this 3.011 into 10 power 23 can also be expressed as half mole of methane or 8 grams of methane. Okay, I hope this discussion is clear. If this is clear, please make a note of it, and if there is any confusion, feel free to express in the comment box. I am looking into it. Okay, so let's discuss few more things. Yeah, let's continue our discussion. Okay, so can you do this question from our discussion itself? You can do this very easily. Number of moles in 12.44 into 10 power 23 number of nitrogen atoms is. See, this many atoms they have mentioned. This many nitrogen atoms they have mentioned. They were asking number of moles of that nitrogen atoms. How simple it can be? So given number of particles are there now, given number of particles by Avogadro number, that gives you the answer, right? So now what you need to take, so number of moles of nitrogen atoms, this is nitrogen atom, always mention this, okay, because nitrogen molecule will be there, atoms will be there, you need to have that clarity here. Okay, nitrogen atoms, how many mentioned? Given number of particles, given number of entities means these particles by total number, that is what? Avogadro number. So Avogadro number is fixed, 6.022 into 10 power 23. Okay, how many entities they have given, how many particles they have mentioned? 12.044 into 10 power 23. So 10 power 23 this can get removed and this becomes 2. Okay, now how many moles we got finally? 2 moles of nitrogen we got. How many? 2 moles of nitrogen atoms we got. Okay, right, remember this. So where do we have? Second option. Okay, is this clear whatever we discussed? Can you do the next question which I have mentioned here? How many moles of atom, how many atoms of oxygen are present in 16 grams of oxygen? See, you need to understand one thing. Oxygen, if they mention in the question as oxygen atoms, what I am saying, oxygen atoms, you should take this as single atom here, but they have mentioned it as oxygen only. See how many atoms of oxygen are there in 16 grams of oxygen. So if they mention just as oxygen, so it will be something like this, O2 form, because in the nature how oxygen exists, it will be in the molecular state, not like O, atomic state. Okay, it will be in the O2 form only. So you need to take a molecule of oxygen. It means the data provided here is not oxygen atom, the data provided is for molecule. So you need to consider this as 16 grams of O2 molecule. Okay, by default from the question itself you should understand, only if they mention it as an oxygen atom, nitrogen atom, you should take it as N or O atoms. But if they simply mention nitrogen, oxygen, means you take molecules like this. Okay, up to here it is clear, I hope. Okay, right. The next what you need to do is how many atoms are there, they are asking in the question. Okay, first you calculate how many moles it will be. See how many moles it will be. Moles of O2 I am finding. How many moles of O2 I am asking. So number of moles of O2 is given weight of O2 by molar mass of O2. Molar mass of O2. So 16, given weight is 16 and molar mass of O2, 2 oxygens are there now. So 2 into 16, that is 32 gram per mole. Okay, so it will be half mole. How many moles we got? Half mole of O2 we got. Okay, now remember here, number of moles of O2 we got it as half mole. This is a fine thing, keep it aside. See, if I say one O2 molecule, what I am saying, one O2 molecule, how many oxygen atoms are there? So 1 into 2. One O2 molecule contains 2 oxygen atoms. How many oxygen atoms? 2 oxygen atoms. Similarly, half mole O2 means you should take it as half mole into in one oxygen atom in one oxygen molecule how many oxygens are there? 2 oxygen atoms. This is called atomicity. I will give you one simple formula conclusion, but just take this as a standard understanding way. Okay, so half mole of oxygen molecule contain half into 2 atoms, because one molecule contain 2 atoms. So this number of atoms are there now, that is called atomicity. What is the atomicity of oxygen here? 2. So first find number of moles, multiply that with its atomicity. Okay, so 2 get cancelled, finally we got 1 mole. So 1 mole is nothing but Avogadro number, 6.022 into 10 power 23. Okay, in a simple way I will tell you one generalized formula now. See, number of entities can be calculated like this. Given weight of substance, from where this given weight of substance is coming? From number of moles. Take number of moles into Avogadro number into atomicity. So what does it mean by this atomicity? It means, for example, I am saying something like this. 2 moles okay, I am saying 2 moles O2, 2 moles O2. So what does it mean? How many moles I mentioned in the question? 2 moles. So 2 into moles. 2 mole means we know 1 mole contains Avogadro number. So 2 into Avogadro number here, 2 moles means 2 Na into, what is the atomicity in the question? See, oxygen molecule, this is a molecule contains 2 atoms. So atomicity here should be 2. So this is your final answer. So 2 into 2, 4 into Avogadro number. Avogadro number means 6.022 into 10 power 23. So upon simplifying this, 24 into 10 power 23, something like this, you will get the final answer. Okay, I hope up to here it is clear. If not, once again look into this, I will be explaining. When they ask number of atoms, like entities means, they may ask you number of atoms in the given molecule by giving some quantity. See, number of atoms in the 2 moles of oxygen molecule. So how can you do? Oxygen molecule means given number of moles multiplied with Avogadro number multiply with atomicity. That's it, like this. Okay, let me give you few more examples to get clarity. Okay, so the question will be like this: number of atoms, number of molecules of nitrogen, number of molecules of nitrogen in 28 grams, in 28 grams. So how can you answer these? So simply by taking, first you find number of moles. How many moles it will be? Number of moles will be given weight 28 grams by its molar mass of nitrogen, because they are asking number of molecules only. Simply you can multiply, divide this with its molar mass of nitrogen also 28 only, so it will be 1 mole. So this is fine, but the question can be asked in the other way also. B, now number of 1 mole. So 1 mole means what you can do? 1 into Avogadro number will be your final answer. 1 into 6.022 into 10 power 23. This is your final answer. But they won't ask you like this. They may extend the question like this. Number of nitrogen, like nitrogen atoms they will ask. Nitrogen atoms in 28 grams of nitrogen. It means if they mention just nitrogen, consider this as a nitrogen molecule. So the nitrogen molecule quantity, how much they mention? 28 grams now. So you are going to get N2 molecules here first. So when they were asking about number of atoms equals to, what I told you, first find number of moles, multiply that with Avogadro number, and then multiply with atomicity. That's it, atomicity. Okay, so number of moles 28 grams, given weight by its molar mass 28 into Avogadro number, that is 6.022 into 10 power 23 into atomicity. What is the atomicity we got here for nitrogen? So nitrogen, 2 atoms are there now, so here take it as 2. Okay, so that's it. So simplify this one time, so this number into 2, so it will be 6, like Avogadro number into 2 is your answer. It means simply you can write 12.044 to 10 power 23. Okay, I hope up to here it is clear. Is there any confusion? Please let me know. Any confusion in the discussion? No, right? Yeah. Yeah, the next one here is, can you do this? How many molecules of water are present in 9 grams of water? It's very simple. Weight is given now. First given weight you convert into number of moles. After finding number of moles, multiply this with Avogadro number. Multiply that with Avogadro number to get the answer. Okay. So first find number of moles. How many moles it will be? Given weight 9 grams by its molar mass 18 grams. For water now, I hope you already got how to calculate this molar masses. So for 18 grams, how can you do this? I mean for water molecule, how can you do this? Simple. How many oxygens are there? 1 oxygen. So 1 into 16. Plus how many hydrogens are there? 2. So 2 into each atomic weight is 1 for hydrogen. So 2 plus 16, 18. That's why I have taken here 18. So 9 by 18 means half mole we got. So they are asking molecules, not moles. So half mole we got. So number of moles into Avogadro number gives you number of molecules. So half mole we got, multiply with Avogadro number. That's it. 10 power 23. So what is your final answer here? So it will be 3.011 into 10 power 23. Okay. So again, once again I wanted to tell you one thing. See, we are at the very basic level, like we are doing this only as a bridge course right now. So that's why I am solving this very basic type of questions. First, if you are clear with this kind of approach, so every question that you are going to see in the class 11th books or 12th books, you can easily solve them. Okay, so do not by heart anything. What I am saying, do not by heart anything. Try to understand them, what is happening in the discussion, how we are approaching the question. Okay, now look at the next question. What is the actual mass of water molecule in grams? Okay, what they are asking, what is the actual mass of water in grams? So very simple, we know 1 mole if you take 1 mole of water molecule, if you take 1 mole of water molecules, if you take it contains Avogadro number of particles. How many particles it contains? Avogadro number of particles it contains. Right now, this many number of water particles it contains. Now 1 mole of water molecules weight is how many grams? 18 grams. So in 18 grams, this many particles are there, this many water molecules are there. How many? 6.02 to 10 power 23 water molecules will be there. Okay, this is the 18 grams is the weight of this many water molecules, but they are not asking for 1 mole, they are asking for 1 molecule, mass of 1 molecule. So this many molecules, 18 grams. So for 1 molecule, how many grams? So this is simple number of you just send this number to that side. So this is x. So this is called a unitary method we are using here. So we need to find how many grams it will be. So now x will be 18 into 1, okay, divided by this number 6.022 into 10 power 23. Okay, let us consider this for simplification purpose as 6 only. So 6 ones are 6 threes are. So what is the total mass we are going to get for 1 molecule? So 3 into 10 power minus 23 grams. How many grams will be that 1 molecule? 3 into 10 power minus 23 grams. Very, very small quantity, right? Yeah, like this. If you take one molecule of water, one small molecule of water, okay, so what is its quantity? Its weight will be 3 into 10 power minus 23. So it's a very small quantity that we cannot even measure. Okay, yeah. So this is what the story of mole concept basics. Okay, and the remaining things that you required extra discussions are, there are many ways to calculate number of moles and its applications. So all those things we are going to do them in the upcoming session. Now what I will suggest you is, you take very basic questions that I have given as a homework here in the discussion. Okay, all these things you can see, few more questions I am mentioning here. You just try to solve all these questions. Okay, if you are able to do them, it's really good. If not, I will be explaining them in the next session. Okay, and if you have any basic, even some foundation books or your 10th class books or any intermediate books, if you have, you just go through these pages, I mean these chapters like mole concepts or some basic concepts of chemistry, it will be mentioned like that. Okay, now you just go through them. If you have any confusion, please let me know. We will be discussing them in the upcoming session. So thanks for watching. Stay connected with our NEET World YouTube channel. Thank you.